Howdy! In this video, we're going to look at radicals. We're going to find square roots, fourth roots, cubed roots, etc. of both positive and negative numbers. We're going to look at properties of nth roots. We've got 5 properties and their examples. Then we're going to simplify rational expressions involving numbers and variables. We're also going to reduce radicals and add them and subtract them, and simplify sum of two radicals. All right, so here we go. We're going to start with the definition of the nth root. So if n is any positive integer, you can take the nth root of a number. Then the nth root of a is defined as this. The nth root of a is equal to the number b if b to the power of n is equal to a. Okay, so for example, the square root of 81 is 9, right? And that is because, I'm going to use shorthand here, because 9 times itself, 9 squared is equal to 81. Okay. Now, the square root of negative 81, you say, well, what number times itself is equal to negative 81? Well, positive 9 squared is positive 81, we just saw, so you might try negative 9, right? But if you square negative 9, again, you have to do negative 9 times itself. So do make sure you have parentheses around that if you are writing it that way. Negative 9 in parentheses squared, right, is equal to negative 9 times negative 9. But a negative times a negative is also a positive. So that doesn't work either, right? In reality, that actually goes into the complex number system, which I'm not going to get into in this video. So it would actually be 9i, but it is, you could say, not a real number. Yeah, so if you're only working in the real number system, you would say square root of negative 81, you might say is undefined is another way to say it. Okay, fourth root of 81. That is different. Now, when we do square roots, we often don't put the little 2 in the hook. That number in the hook is called the index. However, if you have an iPhone, it does actually have the 2 in the little hook on your iPhone calculator. You might pull it out and check it out. But if you have a number there, like it's cubed or fourth root right here, right? Fourth root of 81 means what number times itself 4 times, I'm going to put a question mark, what number times itself 4 times is equal to 81? You might have to think about that a little bit, but well, we already said that, right? 9 squared is 81, and you know that 3 squared equals 9, right? So there's your hint. Let's erase this little question mark here. If I try, this is kind of a guess and check deal here I'm doing, right? But 3 to the fourth, 3 times 3 is 9, times 3 is 27, times another 3 is 81, right? So 3 to the fourth is 81, therefore the fourth root of 81 is 3. And again, you can't take the square or fourth root of a negative, right? Because negative 3 to a fourth power, well, you're multiplying a negative number times itself 4 times. So that's going to be a positive value. So this is also, I'm going to just say undefined, but I mean the same thing as up here. It's not a real number. There is a complex answer there. Okay, cubed roots. What number times itself 3 times is equal to 8? Answer would be 2, because 2 to the power of 3, if we do 2 cubed, I can write my little 3 there. There we go. 2 cubed is equal to 8, right? So cubed root of 8 is 2. Okay, well, what number times itself 3 times is negative 8? So let's try negative 2 and see what happens. So negative 2 cubed, what does that mean, right? That means negative 2 times negative 2 times negative 2, right? And any number times itself 3 times, a negative times itself 3 times is a negative. The first two multiply to a positive, so that's positive 4 times negative 2, which is negative 8, right? So the cubed root of a negative actually is defined. Okay, and so hopefully what you're saying here is that if the index or the root is even, you cannot take it of a negative number. You're going to get undefined. But if that index is odd, and maybe let's write even there. And here, again, you could put a 2 in the hook if you want to. Means the same thing, right? So those are both even. So we cannot take an even root of a negative number, but we can take an odd root of a negative number, because a negative number to an odd power is a negative. Okay, let's look at some properties and then we'll do some practice with simplifying. So let's start with the nth root of a times b. We can split that into 2 radicals if you want to calculate it, or simplify, depends on what you're doing, right? But that can be rewritten as nth root of a times nth root of b. Okay, so for example, here's a useful way to do this, right? If you have a calculator, it's kind of a moot point. You can just type it in the calculator. But if you are doing something where you don't have a calculator, maybe you're taking a test without a calculator, we probably don't want to multiply 8 times 27 and then try to figure out the cubed root. That's going to be a little bit difficult. But hopefully you recognize that both 8 and 27 are perfect cubes. So since we are taking a cubed root, it would make sense to split this into two cubed roots. So let's split it into cubed root of -8 times cubed root of 27. Cubed root of -8 is -2. And since 3 cubed is 27, the cubed root of 27 is 3. So for this one, we do get -6. That was without a calculator. Okay, so these properties allow you to do a little bit of mental math. All right, the nth root of a fraction, we can split that into the nth root of the numerator. So nth root of A over nth root of the denominator, nth root of B. For example, let's say we want to take the fourth root of 16 over 81. You do not have to do this, but you can, or you may want to, split it into fourth root of the numerator, 16, divided by fourth root of that denominator, 81. And the fourth root of 16 is 2, and the fourth root of 81 we saw is 3. All right, so the mth root of the nth root of A, mth root of the nth root of A, right? Why would you do that? Well, it comes up here and there, especially in trig and calculus and so forth, right? What you can do is convert these into rational exponents and kind of see why, but the shortcut is you can multiply those two numbers, the two indices, m times n, and that is your root. Okay, so for example, let's say we want to take the square root of the cubed root of 64. Well, the square root, let's fill in the 2 there, so we can clearly see, oh, we're going to do 2 times 3. We can write that as the sixth root of 64. And that's a little bit strange. You have to ask yourself, what number times itself 6 times is 64? The numbers in these examples are nothing tricky, right? It's not a decimal. It is a whole number. It is in fact 2, right? Because 2 to the power of 6, right? If you multiply that through, you'll see that you do get, in fact, 64. All right, now for the nth root of A to the n. This is a little bit tricky, so pay close attention. The nth root of A to the n does simplify to just A, but only if n is odd. For example, let's say you want to take the cubed root of -5 cubed. Well, let's do it the long way, right? You could first cube -5 and say, well, that's -125. And then you take the cubed root of -125 and you ask yourself, what number cubed equals -125? Well, we just did that, right? The answer is -5. Okay, so the focus here is on the fact that you're essentially plugging into the cubed root of A to the n. You're plugging in -5 and you get out -5. So you get out exactly what you put in. In other words, the cubed root and the cubed power precisely cancel. And I used a negative number, but of course the same does apply if you are doing this with a positive value, okay? And next, the nth root of A to the n. What if n is even? Let's actually do the example first, right? So fourth root of -3 to the fourth. Well, if we work our way from the inside out, we're going to get fourth root of -3 to the power of 4. We already saw that is 81. And then the fourth root of 81. Well, we define that as +3. It is not positive or -3. It is only +3 because if there were two answers, now if you're solving an equation, there could be two answers, right? But we're not solving an equation. We're just asked, what's the fourth root of this number? There can only be one answer because if there was two answers, then the fourth root would not be a function. So think about that. All right. So anyways, the fourth root of 81 is defined as the principal root. It is the positive answer, not the negative number. So it is +3 only. So this one behaves differently, right? We plug in a negative number and we get back a positive number. The sign changed, right? Because when we raise -4 to the -3 to the fourth power, 4 is even. And so that made the number positive, right? Okay, so what function do we know of that takes negative numbers and just makes them positive? Absolute value. So the nth root of A to the n is also equal to the absolute value of A if n is even. Okay, so there's some basic properties of radicals. Now let's do a little bit of practice in applying those. And I'll just go back up as needed to reference those properties, okay? So we're going to start with these expressions, cubed root of x to the fourth. Well, what I want to do is actually just, let me go back up here. I want to apply these rules, right? So the index is 3. 3 is odd, okay? So it's pretty straightforward. The nth root and the nth power do cancel, but the problem is the exponent is 4, right? So what we're going to do to simplify this is split x to the fourth up into two pieces. Let's write it as x cubed times x. And then by that very first property at the top, we're going to split that up into two radicals, which we can then simplify one at a time. So let's split that up into the cubed root of x cubed times the cubed root of x. And then the cubed root of x cubed, since n is odd, right? Let's write this on here. 3 is odd, odd. So therefore, it just simplifies to x. We do not need to involve absolute value bars. So this does simplify to x times the cubed root of x. Okay. All right, the next example, we have the fourth root of 81, x to the eighth times y to the fourth. Now, this is a fourth root, right? And 4 is even. Now, everything inside is not to the fourth power, though, but we can write it so that it is. Because the fourth root, let's see, let's rewrite the inside here, right? 81, we can rewrite that as 3 to the fourth. That's a 4 there. Okay, and we can rewrite x to the eighth as x squared to the fourth. And then we have the y to the fourth, sorry, to the fourth. So what I'm going to do is pull out that fourth power here. Let's write it as the fourth root of, let's group everything in the radical together and write that exponent outside. We can pull that exponent out by exponent properties. So that becomes 3x squared times y all to the power of 4. Okay. Now, this 4 and that 4, we have a fourth root of a fourth power, and 4 is even. So that will simplify to the absolute value of what is on the inside. So that's the absolute value of 3x squared times y. Now you can leave it like that, depends on what you're doing, right? But we could simplify a teensy bit more, because if you're gonna look at the x, if you're gonna square a number, it's already going to be positive anyway. So on the x itself, we really don't need the absolute value bars. So you actually could pull that x squared out of the absolute value if you want to, and write it as 3x squared times the absolute value of 3y. Well, I guess in that respect, we could pull out the 3 also, since 3 is, in fact, a positive number. So let's do that. Let's pull out the 3 and the x squared. Now, we don't know if y is positive or negative, so we do have to keep the bars on the y. Okay, because if you plug in a negative y, this fourth power right here is going to make that negative y into a positive y. So we need the absolute value bars to make sure that our answer becomes positive, because the fourth root is even. All right, and last, let's simplify some radicals and go through here. Okay, so combine radicals to simplify the following expressions. So let's review how to simplify radicals without a calculator. And there's a few ways you can do this. You can do all your work inside the square root. You can do trees. You can do vertical method. There's a lot of different ways, right? So I'll take this opportunity to show you some different ways to do it. Over here on the side, first, I think I'm going to make a tree. So 32. What I want to do is just kind of go back to grade school for a minute here. Let's think of the factors of 32, right? So what is 32 divisible by? You might think 2 and 16, or you might think 4 and 8. Both are good. I'll go with 4 and 8. I'm going to break this all the way down into the prime factorization of 32. So 4 will break down into 2 times 2. 8 we can break down into 2 times 4, but 4 further breaks down into 2 times 2. So you can look at the leaves of this tree here, right? 2 times 2 times 2 times 2 times 2 makes 32, which is 2 to the 5th. Okay, so here's a kind of a shortcut, right, as you group 2 together and 2 together, but let's write it out the longer way first so you can kind of see what's going on under the hood. So square root of 32 we can write as square root of 2 to the 5th. Okay, and then we also need to do the same thing for 200. So I encourage you to pause the video and try this on your own first. So 200, I want to break down its factor tree here, but actually I'm not going to go all the way with that one, because I recognize immediately that obviously breaks down into 2 and 100, right? But 100, I recognize immediately, hey, that's a perfect square. So rather than go all the way down to its prime factorization, we can just say, hey, that's 10 and 10, and 10 square root of 10 squared is 10. So let's just stop there on that one. So we're going to rewrite square root of 200 as 2 times 10 squared. Okay, now what I want to do is simplify square root of 2 to the 5th. Okay, and I'm going to go through all the details, and then I'll show you how to skip over all these details. But for square root of 2 to the 5th, you might think of that as square root of 2 squared, I'll write it out. 2 squared times 2 squared times 2. So I'm doing two twos, and one more 2 for those 5 twos. Now this one I can go ahead and simplify. Square root of 10 squared, we can pull that 10 out, right? Square root of 10 squared is 10. So that does simplify into 10 times the square root of 2. Now each of these, now I've got square root of 2 squared, square root of 2 squared. Each of those turns into 2. Square root of 2 squared equals 2. So there's a 2 times another 2 times the square root of 2 plus 10 times the square root of 2. We can multiply those two 2's together to get 4 root 2 plus 10 root 2. And this is really no different all than, let's just put it over here, then say 4x plus 10x. And I think most people would look at that and say, if you're in school, right, you'd say, oh, that's 14x, right? 4 root 2 plus 10 root 2 is really the same thing, where x is equal to root 2. So you're just going to add those leading coefficients. 4 plus 10 makes 14 times the square root of 2. And that is fully simplified and added. Now, the only reason that we are able to add these right here is because those are the same. And effectively, what you're really doing, another way to do it, is to factor out that root 2 from both terms, which would leave you with 4 plus 10 times square root of 2 if we factor the root 2 out, and then, 4 plus 10 is 14. So there's another way to do it. All right, let's keep going there. You've seen a few ways on that one. So next we have square root of 25b minus the square root of b cubed. Okay, hopefully you recognize square root of 25 is just 5. So we can go ahead and I'm not going to take the time to write square root of 25 times square root of b. I'm just going to pull out the 25 and call that, hey, that's 5 times root b. And then square root of b cubed, we're doing a square root. Square roots do not cancel with cubes, but they cancel with squares. So let's split that b cubed into, since there's just 3 of them, let's just write it out. That's b squared times b. The square root of b squared, okay, ooh, here it gets tricky, right? We are doing a square root, and we have variables. See, in this example, that's all numbers. There's no variables, right? But now we have b. B could be any real number as far as we know. So we have to be careful. So square root of b squared, in fact, I'm going to take the time to split this into 2 roots. Square root of b squared times b is the square root of b squared times the square root of b. Square root of b squared, remember from up here, the index is even right there. So that simplifies to the absolute value of b. So we have to keep that in mind here, okay? So that first part simplifies into the absolute value of b. So we have 5 times root b minus the absolute value of b times the square root of b. Well, let's just factor that square root of b out from both terms. I'll pull it out front, why not? So we get root b times 5 minus the absolute value of b. These are all different ways of writing the same thing. As far as which one's most simplified, you could argue that this is most simplified, or maybe even that the original problem is more simplified. Depends on what you're doing, right? But we're just manipulating these expressions and practicing using the rules. And last in this section, in this video, we're going to look at square root of 49x squared plus 49. Let me pause right before you try something and break the rules, right? That is not equal to, do not do this. You cannot split the square root of a sum into a sum of 2 square roots. That is not equal to the square root of 49x squared plus the square root of 49. Because a lot of people say, hey, 49, that's square root of 49 is 7, right? That would be, and they'd say square root of x squared is, well, that's just x. They'd say that's 7x plus 7. That is completely wrong. Nope. Okay. So why can we not split the square root up over a sum? Let's look at some numbers real quick. If you were to do, say, let's just do square root of, let's go with, how about 4 plus 9? I'm going to do numbers because that makes the point, right? So hopefully you know order of operations. The correct way to simplify that is to add the 2 numbers and you get square root of 13. But if you did it incorrectly and you said, right, and you said, well, let's split that up into square root of 4 plus the square root of 9. Well, hey, square root of 4 is 2, square root of 9 is 3. Those are not equal to each other. The correct answer is square root of 13, okay? The incorrect answer is 5. That's not right, okay? So just be careful, do not split the square root over sum. Instead, what we can do is, since they both have 49, we can factor out a 49. Okay, so let's do that instead. let's take square root of, I'm going to keep it inside the square root for the moment and just factor it out of both terms because that leaves me with 49 times parentheses x squared plus 1. The reason I did that is because we can split the square root of a product into a product of two square roots. In other words, we can split that into square root of 49 times the square root of x squared plus 1, and the square root of 49 is 7. The square root of x squared plus 1 does not simplify. And that's it for this video on radicals.